So here we are, lesson 21, solving quadratic equations by rooting and by factoring. The daily summary says, in this lesson we solve quadratic equations by using the square root property and by factoring. And I just want to first point out that for the first time this semester, we're solving equations with x squareds in them. Okay? We've got lots of practice solving linear equations with just x things in them, but no x squareds. Now we're going to be solving x squared equations for a little while. So let's take a look at number one. In order to solve the equation x squared equals 16, we need a way to get rid of the square on the x. The opposite of squaring a number is taking the square root of that number. So what we're going to do is take the square root of both sides of this equation. Seem reasonable as a way to get x by itself? Take the square root? Yes? Yes. So there's the original equation, x squared equals 18. We'll put a square root on both sides, and that's right there. The square root of x squared becomes just x. We saw that a while ago. Square root of 16 is 4. Super. We have solved our equation, x equals 4. You could have just looked at x squared equals 16, and you probably already knew x equals 4 was the answer. But if it were 17, then it isn't a nice answer, but this process of taking the square root of both sides will still work for us. Here's the problem. X equals 4 is a solution. It's not the only solution. What's the other x that solves this equation? Negative 4, because if you take negative 4 and you square it, which is what the left-hand side says to do, what do you get? 16. It is very easy to miss that negative solution. So here it is in bold. When you take the square root of both sides of an equation, you must put in a plus or minus. So our shorthand solution is here. X equals plus or minus 4. It's just a compact way to say x equals 4 is one answer, and x equals negative 4 is another answer. And so that plus or minus is this symbol right here in the front of the 4. And it's just so easy to forget to do that. You're in the middle of solving a big equation. You take the square root of both sides. At that moment, you got to put in that plus or minus. Okay, number 3 says that taking the square root of both sides is a good technique if the equation has an x squared term but no x term. Let's skip ahead to this equation right here. You are allowed to take the square root of both sides of that equation. No problem. As long as you do it to both sides, good to go. On the left-hand side, what do we get? X. Normally, x equals indicates you are done with the problem. But on the right-hand side, instead of a number, what do we have? We have a square root of 25x, which, yeah, sure, it's 5. Yeah, yes, it's x equals, but that's not the only place the x appears, and that's a problem, right? So it's legal, but not helpful to take the square root of both sides of that equation. What makes it work in this equation is that there was no x term, like the 25x in that last equation, okay? So let's take a look at this guy. It's more complicated. 7x squared minus 1 equals 199 plus 3x squared. There are x squared terms all over the place. Are there any x terms? There aren't, which means that this square root technique is actually in play. It's the easiest way to solve this equation. The first step, where is it? It's right here. First, isolate the x squared. That's the first step. So we're going to group these x squared terms together. Let's move them to the left by subtracting 3x squared from both sides. Is that fair? So when we subtract 3x squared, how many x squareds do we have on the left? 4x squared. So that is here, right? Everything else is copied. 4x squared minus 1 equals 199. Again, the goal is to isolate the x squared. I still need to move the 4 and the negative 1, which goes first. Which one needs to move first? Negative 1 needs to get added to both sides. So that gives 4x squared equals 200. And then how do we move the 4? Okay, so that gives me x squared equals 50. And now that the x squared is by itself, what can I do to both sides to make it x? Square root. That's the new technique, right? If you see x squared equals a number, you take the square root. That's the thing that's the opposite of the square. And you take the square root of both sides, and what do you notice that I included in this line? Plus or minus. So easy to forget that step. It was in the midst of a much bigger problem, but at the moment you take that square root of both sides, you put in the plus or minus. So our answer would be just plus or minus square root of 50, but in this case, we actually could simplify square root of 50. We won't write all the details here. But 50 is 25 times 2. Everyone buy that? Okay. 5 comes out, 2 stays in. Plus or minus 5 root 2 is our final simplified answer. Okay, so that is how you solve equations when there's x squareds, but no x. Now, we're going to solve more general equations, like where? More general equations like this guy right here. Why is the square root not a good tool for that equation? Because you have an x. If it was just x squared and no 5x over there, taking the square root of both sides at some point would be helpful. But if you have both the x squared and the x, that square root property is not useful at all. We need a new technique. So let's talk about this new technique. First, some vocabulary here. Number 5, we now change gears and solve a much broader class of quadratic equations. I'm going to define that phrase right now. A quadratic equation is one that you can write as ax squared plus bx plus c equals 0, where a, b, and c are constant, and a is not 0. For example, this guy right here is a quadratic equation. I don't have the equals 0 yet. It's oftentimes helpful to make it equal 0. So if we move that 5x over, well, it's written down below. I'll just scroll. If I move that 5x over, I get this, yes? And that is a quadratic equation, and it is in standard form, meaning the x squared term is first, then the x term is second, then the constant term is third. Equals 0 is built into what we call standard form. Equals 0. It'll become clear in just a minute why we care about equals 0 over there, but that's the magic number for us. Good question. Okay, so is that legal? Is that equivalent to the original equation? Subtract 5x? Sure, right? We can put these terms in any order we want, as long as you keep the pluses and minuses where they belong. But our definition of standard form says write the x squared first, and then write the x, and then write the number. And so we'll need to sometimes shuffle them around so it just looks like that very particular form. But totally legal what you asked about here. Okay, all right, I think that's good. Just a quick thing about that vocabulary. This is the equation that we just read up above. Ax squared plus bx plus c equals 0. A, b, and c are numbers. We don't need to figure out what those numbers are today, but we will soon enough, so why don't we just try here. A equals, b equals, and c equals. A is always the number touching the x squared. In this circled problem, it is invisible. What is A? 1. Yes, 1 x squared. A is 1. You can take a moment and write down what b and c are. B is always the number touching the x. C is always the constant term at the end. It's tempting to say that b equals 5. That is wrong. B is negative 5. C is the number that's not touching any x. What is it? Negative 24. Good. A, B, and C. Any questions about picking those off of the equation? Okay. All right, so we had our vocabulary. Ultimately, the goal is to be able to solve this purple equation. So let's go back up here and we'll start this process. Okay, number 6. How can we solve this equation that's already in factored form with 0 on one side? 3x minus 1 times 2x plus 7 equals 0. It is tempting to distribute that through. Foil, lobster claw, 2x2 box. It's legal. Turns out you're going the wrong way if you distribute it. This is a really nice form for the equation to be in, and here's why. Suppose that you kind of cross your eyes a little bit so you can't quite see exactly what's in here. There's just some stuff in there, and there's some stuff in there. And I'm multiplying two numbers, and I'm getting 0. If you multiply two numbers and you get 0, what can you say definitively? One of those numbers was 0, yes? I don't know all the details that are in the parentheses, but I am multiplying two things and getting 0. Hey, one of those things had to be 0. Maybe both of them were 0, but at least one was 0. Yeah? So we're going to use that to our advantage. Either this thing was 0, which is there, or this thing was equal to 0, which is there. Yes? That is just this idea of multiply two numbers and get 0. One of them had to be 0. And now we've got two much simpler equations. 3x minus 1 equals 0 we can solve. Could have solved that on the first day of the semester, right? Add 1, divide by 3, x is a third. 2x plus 7 equals 0. Subtract the 7, divide by the 2, x equals negative 7 over 2. Those are the answers, the solutions to that equation. X equals 1/3 and x equals negative 7 over 2. Questions on that? Okay, for the first time all semester, and one equation had how many answers? How many solutions? 2. If you solve a linear equation, it's going to have one solution almost all the time. It's definitely not going to have 2. But it turns out quadratic equations almost always have 2. They're just fundamentally different things than the linear equations we've been solving all semester. Okay, so let's come back to our more complicated one in number 7. Starting with the x squared minus 24 equals 5x. We put it in standard form, which means moving that minus 5x to the left-hand side, put it right there in the middle, 0 on the right-hand side. So x squared minus 5x minus 24 equals 0. We call that standard form. This guy right here, the left-hand side, is a trinomial, and you could factor it using the 2x2 box. It's just an example that you did in the, kind of like the ones you did in the activity, yeah? So we're not going to spend our time together using the 2x2 box. I'm just going to say, this is what you get when you factor using the 2x2 box. X minus 8 times x plus 3. There's a lot of work involved in going from that first circled equation to the second one. I don't want to make it seem like it should be instantaneous for you guys. But when you do that work and you do the whole box thing, it becomes factored and you get that. But now that you get that, again, you can kind of blur your eyes a little bit and say, hey, I'm multiplying two things and getting 0. What has to be true? One has to be 0. And so you just break it up into two equations. Either this one is 0 or this one is 0. And you solve that first equation by doing what to both sides? Adding 8, get x equals 8. How do we solve the second equation? Subtract the 3, and you get x equals negative 3. Those are our two answers. I'll highlight them in yellow. These are the answers to the equation highlighted in yellow. Those are the solutions. Again, we got 2. Questions on that? Okay, some folks have this kind of shortcut memorized. If you have an x minus 8 in the parentheses, that minus 8 for some mysterious reason becomes a positive 8 at the end. That positive 3 for some mysterious reason becomes negative 3. I don't want it to be mysterious, and I don't want it to be memorized. I don't want you to memorize whatever the number is in the parentheses. You just randomly change the sign in the final answer. It's true in this particular case, but if that's something you memorize and you don't understand just this simple idea that you are solving two little equations equal 0, then you are not in a good position to solve when it's a little bit more complicated, like right up here. If you just memorize this kind of special case, so whatever that number is, just change the sign and that's the answer, it's wrong, yeah? The answer to this one was not x equals 1, it was x equals a third, because you are solving that thing equals 0. So even for the easy ones, yeah, even for the easy ones, encouraging you guys to just write that equals 0 equation and then just go through the steps to solve it, even if it's something you could just solve in your head in half a second. Okay, activity starts on the next page. Let's see how far we can get.